All right, let's look at the sprite classes that I created. The first one is CDice. Now, CDice is a class that creates the cubes that you see that fall down. Those two cubes with the smiley face and the sad face. Okay? That's what CDice creates. Okay. So, you'll notice that there isn't very much in the definition, but the key thing here is to notice that it derives from C-Physics Body. Now, C-Physics Body is a base class that I created that encapsulates all of the Cocos 2D process to create a sprite. And that would be this code here. See, it says create static body boundary. Well, I left this code here so that you can see what it entails that you have to do every time to create a sprite. All right, you have to do all these lines of code. Compared to what you see here with the C floor, that it's only a few lines. Okay? So, this is the part that's in the base class. And we'll look at that shortly. But right now, this is the definition. Let's go to the implementation of the dice class. You notice that there isn't very much either, but it does. There is a method, and there's two constructors. There's a default constructor, which creates its own world and makes a self-contained sprite. At any time, you can change that information. Or you can use the other constructor, which passes the parameters and allows you to make this dice part of your environment in the main scene. So as you can see, it passes in the world object, the gravity object, and it's these two components that integrate this sprite into your environment. The rest of the information is how to generate the sprite, characteristics of the sprite. All right? So let's look at the floor class. As you can see, it's very similar to the dice class. Most of the work is being done by the base class, C-Physics Body, that it derives from. Okay, and if we look at the implementation of that class, you'll see that again, it's very similar. All right, so let's look at the image, the C image sprite. Now, this class that you see here, C floor, before we go and look at that, that class creates what you see here. There's a platform that the dice is sitting on. That's what C floor creates. That's a sprite. And that sprite has a static body. All right? So, the class we're going to look at now, C image sprite, generates these two objects here. You're looking at the dice. This one, the left die with the number 3, and the right die with number 4. So C image sprite generates these two sprites that are also static bodies. All right, so let's go in and look at that. All right, so we'll look at the definition. Now, as you can see, the definition is very similar to the other two classes. The difference is that now here we've added some value, and because we're deriving from C-Physics Body, the information, the creation of the sprite is encapsulated, and all the information that has to deal with that sprite is also encapsulated, and we don't run the risk of having all the code in one class and mixing and matching and copying and pasting and having other issues. So this adds an enumerated type that defines the images, which are the face of the dies, 1 through 6. There's a method that you pass in this enumerated value, and then it will pass the proper string to the sprite texture, and it'll have that die. And then there's also a method that makes the sprite visible or hides it. So let's look at the implementation file. As you can see, it has the default constructor, just like the other two. And it also has the parameter passing, just like the other two. The difference here is that you'll notice that this is that set image method that I was talking about. And what this is doing is that you pass in an enumerated type, and that type represents the particular file. And then I take that information and I pass it on, and I set the image of the texture for the sprite. Now, you notice that I'm preceding that set method, that set image method with the word cPhysicsBody. Because I derive from cPhysicsBody, I'm telling the derived class I want to execute the set image method in cPhysicsBody. If I left this out, then I'd have a recursive loop. So recursion would occur because set image would call the set image of the derived class, and then it would be an infinite loop. So by specifying which one I want, I avoid the infinite loop issue. That's why this is here. And this method, visible, you pass in a state true or false, and that will determine whether the sprite is visible or not. And again, notice the cPhysicsBody attribute that tells the derived class which one of the two versions I want to execute. All right, so let's go and look at the PhysicsBody derived class. So we'll look at main scene first, and remember that this is all the code here that says create static body boundary that you have to do for every single sprite that you create, and it all has to reside in the main scene class because that's the scope of your scene. All right, so let's look at the derived class. You'll see that this class is more substantial, and it has data members who hold the body definition, the fixture definition, the gravity definition, the world object, the shape, the body, and the actual sprite that's there. You'll also notice there are enumerated types that are defining the shape types, that define the body types, and that also define the parameters for velocity and position. So, also notice that each one of these begins with an unassigned body or unassigned shape or unassigned value. The reason why I do this is by default I set up the data members with the default value. Now, as I'm generating the code and designing the project and implementing the project, if I happen to forget a part of the code, then this initial variable will show up and it'll cause an error. And that tells me that I need to complete something. All right, that's why I do that. So come down here and I'm defining some constants that I use throughout the code. So this is to keep me from having magic numbers all over the code. All right, here's the velocity iterations and the position iterations defined. Notice I'm using the default constants to define those values. I set up two more constants that have to deal with a default image and also deal with the default point. You'll see your constructor and destructor definitions. Here's the method initial component. As you can see, it passes in the world and gravity objects to integrate into your environment, and the rest of these define the parameters. You'll also notice that there are these methods, gravity, get methods called gravity, body def, fixture def, world, body, sprite component, and body shape. The reason why I make those objects available that are in the base class is because Cocos 2D has this issue where this information has to be operated on from within the scope of the main scene. So that's how it gets integrated. And I make it available in this fashion. There are set and get methods for friction, density, restitution. There's an update fixture method. Here's the visible and set image methods that we saw in the derived classes. All right, so let's look at the implementation file. Okay, so you notice there's the constructor, destructor. We have this initial component method, and you'll see that the world is being passed in and the gravity is being passed in, and the rest of the values are characteristics for the sprite. As we come down, you see I'm setting the values accordingly to the data members. Then I'm creating the sprite. I'm setting the position of the sprite. I'm setting the scale of the sprite. And now I'm working with the body definition. And I'm using this case statement to determine, depending on the choices, which one of the constants that get assigned to the body def type. Here's the body def position, which is the point that was passed in. Here's the sprite member that gets used as user data. Then using the world object, I create the body with the body definition, and we have the body object. Now I've come down here and I'm dealing with the type. So there's, you define when you're dealing with the fixture and the shape, there's circle. This is the task that's performed when we do the circle. As you can see, it defines the circle type. It sets up some of the parameters. It sets the circle object to the shape in the fixture def. And then it also saves it as the shape object, the shape data member. And we do the same thing with the edge shape. It uses edge shape defined. Chain. Polygon shape, as you can see. And then we come down and define all the other components of the fixture definition. And then we create the fixture using the fixture definition. You should take note of, see this shape data member? If we go and look at the shape, the declaration of the shape data member, you'll see that it is of type B2 shape, okay? Now, B2 shape is a base class that the B2 fixture def derives from. And because it derives from it, then we can assign the body, we can assign the object to that pointer. And because the derived class is derived from it. This keeps us from having several different versions of the shape variable to handle different cases. All right, so let's go back to body. So you see that, it's created, and that's the end. Here's the set image. You see that the file name comes in. It's set to the texture of the sprite component. Here's where we make the sprite component visible or invisible, visible or hidden. This updates the fixture. Whenever we change any of the properties, we need to execute this method to update the fixture. Here's where we set the friction value. Here's where we set the density, the restitution. Here's where we get the information, where we get the density, we get the friction, and we get the restitution. Here's where the gravity object is returned. Here's where the body definition object is returned. The fixture def is returned. The world object is returned. The body object is returned. And here is where the sprite component is returned. Now you have to return the sprite component because you have to add it to the add child collection within the scope of main scene, which is your main scene that's there. All right, so again, let's look at main scene and the static body boundary, and that's the code that this replaces. So as you can see, by doing this, creating this base class and deriving from the base class, we minimize the issues of having all this code within the main scene class. But also, every time you have to create all of this, this is prone to errors. You can put the wrong values in there when you go and modify it afterwards. You can forget to define values. It's very problematic, and it all gets bunched together in one place, and that is not a good design to deal with. You want to encapsulate that work, and then you want to also encapsulate all the value that you added to that particular sprite. And that's what we're doing with these classes and the base class. All right? So that pretty much covers the definition of the code that generates the game. Again, here is the game, home screen. We go to the main screen. We select odd. We roll the dice. You'll see that the top die comes down onto the bottom die and forces it to start spinning. Hopefully we can see it go to the end. You'll see it falls off the edge. The other one will eventually fall off the edge. This is the capture program affecting the physics engine.
Yay!
In this particular case, the person won, and you hear the cheering, and this is the value of the die. 6 and 3, which is 9, and that's odd. Right? So, that concludes the video, and I hope you enjoyed that, and I'll see you next time with some more games that I'll be creating this year. Thank you.